All right, last section of chapter 5, area between two curves. This is kind of an expansion on 5.4. We're still doing the same idea, but it's a little more complicated because we have two different things we're looking at, and we're looking at the area between them. So how we do this is we take, so if my f is my function that's on top, my g is on bottom, over the whole interval. If it changes, we deal with it a little bit differently, which we'll get there. Then I take the area under F, which is going to be this big yellow splotch. It's fun to color, not gonna lie. All right, you don't need to watch me color a little bit more. Okay, so we take the area under F, and then if we subtract the area under G, what are we left with? Just the yellow bit. So that is exactly what we're going to do is take the area of the top function minus the area of the bottom function. That'll get the area between the curves. We've kind of been doing this, but we haven't said that's what we're doing. So when we have a multiple or a more complex function, that's what we're doing. So it is very important to graph these. It's not always obvious which is your bigger function. And sometimes within the function itself, it changes. And we're going to deal with some of those cases. So if you don't want to graph them by hand, I don't blame you. This can get really tedious. Throw it in Desmos, find the graph there, and then it might help to, once you have a picture of it, to kind of do a really crappy sketch on your page itself and say where interesting things happen. But that's not 100% necessary. I find it's helpful. Okay, we get to deal with my really bad drawings today. First thing I'm going to do, we're going to find the area between x squared plus 2 and y equals x. This is the easy one, so I'm going to graph it first. There we go. 3, 3 would be here. All right, and I'm not going to shade anything yet because I don't know where to shade. All right, and then x squared. If I plug in 0, I get 2. If I plug in 1, I get 3. I did not leave myself enough space, did I? Oh, no, I did actually. Okay, and we want the area from 0 to 1. Okay, so the pink graph is on top. Black, I suppose. So we go from 0 to 1. This one is always on top. So minus y equals x dx. And this is just a standard integration problem for us now. So antiderivative is 1/3 x cubed minus 2x, well, plus 2x minus 1/2 x squared. It bothers me that they're not in descending order, but I'm going to let it go. All right, plug in 0, I get minus 0. My calculator is going to do the work for me. Okay. The area should always be positive. If your area is negative, that means you switched which function was on top. You're at the wrong one. But if you think about it in regular life, area is always positive. So the area between your curves should always be positive. Last section, we could get negative areas because of how we were looking at things, but here we should not. So if you do, that is a good indication that something went wrong. Look at your graph again and see what it could have been. All righty. I did not draw this out. Sometimes I forget that I should work problems before I get here. All right. 2, 4. This, okay. Again, this will be blue. We're going to deal with some that aren't this nice little function. Okay, this says the area between. So we're not given our limits of integration. We have to figure that out. So 0, 2, if I plug in 1, I get 1. If I plug in 2, I get -2. It's gonna mess up my next problem a touch, but that's okay. Okay, what's important here is figuring out where our two functions meet. So if you have good graphs or a good calculator, graphing utility of some sort, a lot of times you can figure it out, you can eyeball it. If you don't, or if it doesn't connect at a nice place, set them equal. So you'll say x equals 2 minus x squared. So all I did was set my two functions equal and solve it. So bring everything over. I get x squared plus x minus 2 equals 0. Factor x plus 2, x minus 1. Get -2 and 1. And hey, that looks like exactly what my graph told me it should be. So those are my limits of integration. Let's go back to black. So I go from -2 is smaller to 1, my top function, 2 minus x squared minus my bottom function, dx, integrate. 2x minus 1/3 x cubed minus 1/2 x squared from -2 to 1. 2 times 1 minus 1/3 1 cubed minus 1/2 times 1 minus, in parentheses, 2 times -2 minus 1/3 -2 to the third minus 1/2 -2 squared. All right, calculator time. 2 minus 1/3 minus 1/2 minus parentheses -4. That's going to be positive 8/3 minus 2, right? Yeah. 9/2. There's really no good way to check this unless you throw it in something that lets you cheat. I know they exist. All right. Leave that on the screen a second. Okay. Okay, yeah. 2 more of these and then we'll call it a day, because it's really just practicing more of the same. So find the area of the region bounded by y equals x squared minus 3x minus 4 and the x-axis. Well, the x-axis is just this guy here. So we want to figure out, sorry, dreaming. Want to figure out what this looks like. So, I don't want to draw this out by hand. I didn't think this through, excuse me. I'll hide those for a moment. What was my function? X squared minus 3x minus 4. Okay. So it looks like we cross at 0 and 4. So we see our function, the area underneath. Am I going to be able to, you can be able to see my mouse? Yeah. So it's this area here. X equals 0, and excuse me, y equals 0 is our top function. So I go from, I said, -1 to 4 of 0 minus our equation, x squared minus 3x minus 4 dx. Okay. Which is going to give me -1/3 x cubed plus 3/2 x squared plus 4x from -1 to 4. All right. I am just going to plug this in. So -1/3 4 to the 3rd plus 3/2 4 squared plus 4 times 4, which will be 16, gives me 56/3 minus, now I'm just going to plug in the -1. I wrote it in my calculator weird, so now I have to fix it. Okay, I get 125/6. So I am going to trust that I button pushed that well. Looks good. Okay. Last one, we're going to find the area between these two functions. And I said that my graph is loaded there, so I didn't forget, but I did not forget. So these guys are going to be interesting. Here's my f of x function. So it's a, nice, it's not a parabola. It's a cubic function, so nice and goofy. And here's my g. On my graph, I can tell where they meet. So it looks like f is on top for the first interval and g is on top for the second interval. And we really only have 2. So the area here and then the area here. So where my f dominates, it looks like they meet at -2 to 0. So -2 to 0, f minus g. We'll clean this up later. And my g dominates from 0 to 2. Look back at our graph. And they never meet again. So that's the area in between our curves. Just be very careful as to which one wins, which one dominates. If you get it wrong, you're going to get the negative of the answer we want. And in this case, my graph is really good. I can touch some of these guys and see where the points meet. It's going to tell me. Oh, look at that. I wish I had this one. I was learning calc. So it tells us our values. If you're not given something that lets you do that, you're going to have to set the functions equal and solve. Gets a little messy, but it's math. It happens sometimes. Okay. Honestly, the hard part is behind us. Now we just need to calculate. Or the hardest part is behind us. Okay, so from -2 to 0, my f function is first. 3x cubed minus x squared minus 10x. I'm going to subtract my g, which is changing all of its signs. I'm going to clean that up a step. All right, 0 to 2. Now my g is on top. Minus my f function, change all of the signs. Okay. Going to combine like terms. Is that my only cube? Let's cancel. That is far, far nicer. Yeah. All right, those cancel. I get -3x cubed and plus 10x, 12x dx. Oh, fireworks are going off again. Thank you, neighbors. Okay. Now we integrate. So I get 3/4 x to the 4th divided by 2, 6 x squared. I'm going to go from -2 to 0 plus, hey, it's going to be the same thing but backwards. Plug it in. All right. Oh, I plug in 0 first. I was wondering how this was going to turn out. I forgot my rule. Minus 3/4 times -2 to the 4th minus 6 times -2 squared plus, plug in my top number, -3/4 2 to the 4th plus 6 2 squared minus 0 because that's going to 0 out. Alrighty, bye. -3/4 times 16, right? Minus 6 times 4 minus 3/4 times 16 plus, ooh, something has gone wrong. There it is. 6. A lot of math to get 24. Did I forget to write the end? I did. Sad. Okay, so that's this section. Honestly, the hardest part is the graph, and I don't have that picture up here. So use your tools, figure out how to graph it the best you can. Note which function's on top. If you get out a negative answer, you know you've done something wrong, something blew up on you. So that is that. We are done with chapter 5. I will be taking the very last section of that off. I think it's beyond the scope of class, and plus we have a lot to get through and want to overload you more than necessary. Then we have chapter 6 and we're done. And I want to say there's only 4 sections of 6, so hopefully that won't be too painful. All right, I will see you next time.